they've taken the square root of negative 25 and they divided it into the square root of 25 times the square root of negative 1, because the square root of negative 1 is I. Okay, so they factored out the negative 1. Then we do separate square roots. So the square root of 25 was 5. The square root of negative 1 is I. Okay? So our final answer would be 5I. In this next example, the negative square root of negative 48, we're going to factor out the negative 1. So that gives me minus square root of 48 times the square root of negative 1. Okay, separate the roots. Okay? So if I'd written it, I kind of jumped ahead there. If I'd written it this way, then my next step would be divide it into two separate roots. Okay, factor the perfect square. Okay, well, 48 is not a perfect square. So I'm going to go back to our two-column method. And I'm going to say, well, 2 goes into 48, 24. 2 goes into 24, 12. 2 goes into 12, 6. 2 goes into 6, 3. So I've got 2 pairs of 2's and a 3 left over. Okay, that's negative, because that negative is still in front. 2 times 2 is 4, times the square root, and the 3 goes back under the square root symbol, and times the square root of negative 1. Then to simplify it, we're going to say, well, that's negative 4 square root of 3 I. And we've expressed it in terms of I too. Now, the only thing is that I is in the back, right? So my last step is I'm going to put the I up there with a whole number. So it's negative 4I times the square root of 3. And the reason that we want to do this is because sometimes we let our square root symbol come out a little bit too long. That line on top is called the vinculum. And sometimes we let the vinculum just trail out too long. It might go over the I. We don't want that. So just to be safe, we put the I in front. Okay? Now, complex numbers are numbers that can be written in the form of A plus BI, where the A part is the real number and the B times I part is the imaginary. Now, the reason that this is important comes in with a complex conjugate. So we talked about square roots of positive numbers give us reals. Square roots of imaginary numbers, well, they're square roots of negative numbers. So a combination of the two has a real part and an imaginary. If I go for the complex conjugate, I'm coming up with the other value that I can multiply times that complex number. Yes, sir. Do you have those tests for me? Okay. Actually, just bring them to me. I'm sorry, I'm videoing, so I'm trying to keep it real short. Thank you, sir. Okay, so anyway, the complex conjugate is the number I could multiply times the first complex number and get a real number back. So if the complex number is A plus BI, the complex conjugate will be A minus BI. Since 5I is only imaginary, it doesn't have the real part listed, it's actually 0 plus 5I. And so if I plug in the 0 for A minus BI, it'd be 0 minus 5I, which is negative 5I. Okay, so let's do these examples together. And they extracted the perfect squares out of these for us. That was really nice of them to help us out, but we use a little different method for ours. What we can say is, well, the square root of 36, we know that's going to be 6. And the square root of negative 1 is going to be I. And we can't take the square root of 2, so it goes back under the radical. Okay, on number 2, we've already got 4, so I'm going to write this down in 2 steps. I'm going to take the square root of 9, which is 3. I'm going to take the square root of negative 1, which is I. I cannot take the square root of 5, so it stays back under the radical. So this would end up being 4 times 3, which is 12, I times the square root of 5. Okay, now, for demonstration's sake, I'm going to do number 3 using the 2-column method. Okay, I know that you know what the square root of 100 is, but I'm going to write it as the square root of 100 times negative 1. I'm going to show my 2-column method just so you can see it for practice sake. So 2 goes into 100 50 times. 2 goes into 50 25. 3 won't go into 25 evenly, but 5 is a prime number, and they'll go into 25 5 times. 5 is prime, so I stop there. Cancel out everything that's not prime. Circle my pairs of numbers. So that gives me 2 times 5. I don't have any leftover pieces. And then the square root of negative 1 is I. So that would be 10I. 5 times the square root of negative 54I. Okay? Again, 2-column method. I will write down before I go there, 5 times the square root of 54 times the square root of negative 1. Okay? Now, the 54. 2 goes into 54 27 times. 3 goes into 27 9. 3 goes into 9 3. 3 is prime, so I stop there. I've got a pair of 3's and a 2 and a 3 left over. So that's going to give me 5 times 3. I've got the square root of negative 1, which is I, times the square root of 2 times 3, which is 6. So that's 15 I times the square root of 6. Okay, 2 square root of negative 64. That'd be 2 square root of 64 times negative 1. And what is the square root of 64? We should have that memorized. What is it? 8. So, okay, well, if you don't, then we can always go back to our 2-column method. 2 goes into 64 32. 2 goes into 32 16. 2 goes into 16 8. 2 goes into 8 4. 2 goes into 4 2. So, if we don't have it memorized, that's totally fine, So I have a 2 in front. I've got 3 pairs of 2's, so times 2 times 2 times 2. All my pairs go outside the radical. I don't have anything left to go back underneath it. And then the square root of negative 1 is I. So that'd be 2 times 2 is 4, times 2 is 8, times 2 is 16I. All right, and then negative square root of negative 98. Well, let's see. 2 goes into 98 49 times. 7 goes into 49 7. 7's prime, so I'm going to stop there. So I jumped ahead. I should have written square root of 98 times square root of negative 1. So let's see. I've got a pair of 7's. The 2 goes back underneath the square root. And the square root of negative 1 is I. So negative 7I square root of 2. Now, the last three, they're asking us to find the complex conjugate. So if I have negative 9I, this is equal to 0 plus, or minus, 0 minus 9I. The complex conjugate would be, and it's not equal to this, but the complex conjugate is 0 plus 9I, which would be equal to 9I. Okay? The complex conjugate of 1 plus 4I is 1 minus 4I. And the complex conjugate of 12 minus I is 12 plus I. So again, we're just taking the sign of the complex part and reversing it. Okay? Now, if you go to the back, it says you can use square root property and square root of negative 1 equals I to solve quadratic equations. And they give us some examples to work out. Okay? So I'm going to skip down here to this one. And you can look back at the previous one before. Okay? If you want to practice a little bit. I'm going to subtract 80 from both sides. So that would give me 5x squared equals negative 80. Okay? I want to divide both sides by 5. Okay, so when I do that, that gives me x squared equals, and negative 80 divided by 5. How much would that be? 5 goes into 8 once and then to 36. So x squared equals negative 16. Okay, my next step is take the square root of both sides. So I'm going to take the square root. And you know that whenever I take the square root of something to solve the equation, we get two roots, right? X equals plus or minus the square root of negative 16, which would be 16 times negative 1. We know that 4 times 4 is 16, so this would be plus or minus 4i. Now here's the thing. Because it was a quadratic, because this was x squared, I should get two solutions, guys. Two solutions. That means that I need both the plus and the minus in my answer. If I don't get the plus and minus, then I've only listed half the answer. It's going to be 50% off. So 50% off is great when you're doing Christmas shopping, but it's not great when you're getting points. So you want to make sure that you list both the positive and the negative root. Okay? Now, if I were to check each of the two roots, okay, by plugging it back into the equation, 4i times 4i would give me 16i squared which would be 16 times negative 1, or negative 16. Okay? Matches up here. If I have negative 4i times negative 4i, that would give me negative 4 times negative 4 is positive 16. I times I is I squared. Again, we know that I squared is equal to negative 1. So that would also give me negative 16. So both roots work, right? They both give me a negative 16 back. So we've got some examples down here to work out. First one, they've extracted the square root for us. So the square root of 9 is 3. Square root of negative 1 is I times the square root of 2. Okay, and this next one, they didn't quite take it as far as we did. We said, well, x squared, if I divide by 6, that will equal negative 4. I'm going to take the square root of both sides, put my plus or minus in front. So x will equal plus or minus, square root of 4 would be 2, so it'd be 2i. Okay, number 12, subtract 49 from both sides. So x squared equals negative 49. Take the square root of both sides. I've got to put my plus or minus in front of that. Move it over a little bit so y'all can see better. So plus or minus. So x equals plus or minus the square root of 49 times the square root of negative 1, or x equals plus or minus 7i. Okay, now, number 13 is going to work out really nice too, because again, we're working with a perfect square. So x squared equals negative 100. Take the square root of both sides. That goes plus or minus. So x equals plus or minus the square root of 100 times negative 1. So x equals plus or minus 10i. All right, now on this number 14, we're going to divide by 3. Oh, I don't want to divide by 3 yet. What do I want to do first? What did I do first on all of these others? Yeah, there we go. I was getting ahead of myself. So 3x squared equals negative 108. Then divide both sides by 3. So x squared equals negative, and 3 will go into 10 3 times, and then to 18 6 times. Take the square root of both sides. And when I do that, I've got to put my plus or minus in front. So x equals plus or minus the square root of 36 times negative 1, or x equals plus or minus 6i. Okay, one more, number 12, or number 15. I'm going to subtract 12. So x squared equals negative 12. Take the square root of both sides, and that puts the plus or minus in front. So x equals plus or minus the square root of 12 times the square root of negative 1. Now, 12 isn't a perfect square, right? So let's do a little side work here. 2 goes into 12, 6. 2 goes into 6, 3. 3 is prime, so I'm going to stop there. I've got a pair of 2's and a 3 left over. So we've got x equals plus or minus. The pair comes outside the square root. The square root of negative 1 is I. And then we've got the 3 left over. It goes back into the square root. Okay? Main thing to remember, guys, you've got to remember that plus or minus when you're solving the equations. Okay? You've got to make sure you do that. Because if you don't, it's going to cause you issues with your final solution. Okay, so